Hello students, this is 12th standard paper 2 chapter 2 as logic gates. So here in this chapter we are going to study about gates. So what is a gate? What are the types of gates? Different types of logic equations, different types of logical circuits, how to make complicated logic circuits and make them simple. So all these points we are going to study about, and how the first chapter number system introduced different binary arithmetic procedures, how they can be designed in a circuit way using these gates. या चॅप्टर मध्ये गेट म्हणजे काय, गेटचे टाइप्स, त्यानंतर गेट सर्किटचा वापर वेगवेगळ्या इक्वेशन नुसार कसा करायचा, कॉम्प्लिकेटेड लॉजिक सर्किट सिंपल कसं बनवायचं, आणि नंबर सिस्टीम ह्या पहिल्या चॅप्टर मध्ये जे आपल्याला प्रोसिजर्स बायनरी अरिथमेटिकचे ज्या सांगितल्यात, बायनरी ॲडिशन, बायनरी सबट्रॅक्शन, त्याचे सर्किट्स कसे डिझाइन करायचे, हा पार्ट आपण या चॅप्टर मध्ये बघणार आहोत. ओके, सो फर्स्ट अबाउट व्हॉट इज अ गेट. गेट इज अ लॉजिक सर्किट विथ वन ऑर मेनी इनपुट्स. इनपुट्स किती आहेत म्हणून सांगितलं, वन ऑर मेनी. डायरेक्टली आपण मेनी इनपुट्स म्हणू शकलो असतो, बट देर इज अन एक्सेप्शनल गेट which has only one input one output. आपल्याला डेफिनेशन मध्ये मेनी इनपुट्स वन आउटपुट म्हणता आलं असतं, पण इथं काय आहे तर असं एक गेट आपल्याला लक्षात येईल की ज्याला एकच इनपुट आहे आणि एकच आउटपुट आहे. म्हणून डेफिनेशन मध्ये काय सांगायचं, गेट इज अ लॉजिक सर्किट which has one or many inputs but only one output. Okay, so it is a logic circuit. Basically what is a logic? Logic, normally whenever we are discussing something, then it may be said like that. Logically think, thinking, conditional part. Similarly, here these circuits, they are going to make decision making. So whatever latest is the robo that manufacturing, it is totally dependent on artificial intelligence, and the base of these robotics, it is nothing but decision making gates, as they are the logical circuits. So conditions, they have to be given, and according to those conditions, whether that condition is true or false, whether it can generate the output as high voltage or low voltage, like this we are going to make some conditions. Gate मध्ये आपण हा सगळा पार्ट आता शिकणार आहोत, ज्याला एक इनपुट किंवा एकापेक्षा जास्त इनपुट्स असतील, पण आउटपुट मात्र काय असणार आहे, एकच. असा हा लॉजिकल म्हणजे थिंकिंग म्हणजेच डिसिजन मेकिंग सर्किटचा पार्ट म्हणजे गेट. गेट इज अ लॉजिक सर्किट विच हॅज वन ऑर मेनी इनपुट्स but has only one output. So here what is a logic? Logic is nothing but decision making. So the logic, it shows condition or statement. So gate recognizes some of the conditions and neglects or ignores few conditions. So whenever it recognizes those conditions, output becomes 1. Whenever it ignores them, output becomes 0. It means whenever condition is true, output will be 1. Condition is false, output will be 0. 1, 0, language of either high voltage or low voltage. Digit 1, digit 0. So that is nothing but digital circuit, correct? So the input status will be either 1 or 0. Similarly, the output combination will be either 1 or 0. Here it is about logic. So logic is nothing but condition or statement, but the same logic, it can be represented as either high voltage level or low voltage level. Either the condition is true or false, either the answer is 1 or 0, either it is in on state or off state. So in digital circuits, two types of logic levels are considered, and they are positive logic and negative logic. So what about positive logic and negative logic? Digital circuit मध्ये आता आपण हा जो लॉजिक सर्किटचा पार्ट आहे, हा पॉझिटिव्ह लॉजिक आणि निगेटिव्ह लॉजिक अशा दोन फॉर्मॅट्स मध्ये बघतोय. So what about positive logic? Here it shows digit 1 is used to show high voltage level from given two voltage levels. ज्या दोन व्होल्टेज लेवल्स दिलेले असतात त्यातल्या हाय व्होल्टेज, मोर पॉझिटिव्ह व्होल्टेजचं रिप्रेझेंटेशन डिजिट 1 नी केलं जाईल, आणि झिरोचा पार्ट हा लो व्होल्टेजनी दाखवला जाईल. 0 हा वापरला जाईल लो व्होल्टेजसाठी. बट एक्झॅक्टली अपोजिट इन केस ऑफ निगेटिव्ह लॉजिक. अपोजिट 0 is used to indicate high voltage, 1 is used to indicate low voltage. बरोबर उलट घडणार आहे. पॉझिटिव्ह लॉजिक मध्ये नॉर्मल जसं आपण विचार करतो 1 म्हणजे हाय व्होल्टेज, 0 म्हणजे लो व्होल्टेज, पण एक्झॅक्टली अपोजिट निगेटिव्ह लॉजिक मध्ये 0 या बिटचा वापर केला जाईल हाय व्होल्टेज दाखवण्यासाठी आणि 1 चा वापर केला जाईल लो व्होल्टेज दाखवण्यासाठी. एक्झाम्पल, suppose +5 volt and 0 volt, two voltages are mentioned. So in case of positive logic, yes, 1 will show high voltage +5 volt and 0 will show 0 volt low voltage. But in negative logic, exactly opposite thing will occur. 0 volt will be indicated by digit 1 as a low voltage. 1 is going to represent low voltage and 0 is going to represent high voltage, that it will show +5 volt. So this is about positive logic and negative logic. Then other example, as given voltage levels are -4 and -1. -1 is more positive than -4. So here it shows as -4 volt as -1 volt as high volt by digit 1 and -4 volt by digit 0 in positive logic. But in case of negative logic, 1 will show here low voltage, that is -4 volt, and 0 will show -1 volt, that is high voltage. Okay, so -1 indicated by digit 1 in positive logic, -4 as low voltage indicated by 0 in positive logic. But in negative logic, digit 1, it is going to introduce low voltage. Low voltage is -4. Digit 0 in negative logic shows high voltage, that is nothing but -1 volt. So this is about what is a gate, what is logic, what are the two types of logic systems used in digital circuits, about positive logic and negative logic. Next part, we will find what are the conditions, how they can be written. About the gate, as gate is a digital logic circuit with one or many inputs and only one output, how to represent that conditional part about the gate? So it is known as its logic, that is condition or statement. It is also known as the condition for which the gate recognizes that input combination by making output 1. So that is logical equation, logical expression, or it is also known as Boolean expression. Why it is known as Boolean expression? Because English mathematician George Boole, he invented a new way of thinking and converting those thoughts into some conditional part and making the answers either yes or no, true or false. So that technique, it made nowadays how digital electronic technique has been made very simple, how ICs got fabricated and how it has led as reducing the size of the circuits as well as enhancing the speed of those circuits. So the whole effort is given or introduced by George Boole, English mathematician. So in the honor of that scientist, English mathematician, it is also known as Boolean equation. George Boole या इंग्लिश मॅथमॅटिशियननी असा एक प्रयोग करून बघितला की ज्यामध्ये आपण ज्या कंडिशन्स विचार करतो त्याचं उत्तर एकतर येस किंवा नो, ट्रू ऑर फॉल्स अशा पद्धतीने आलं पाहिजे आणि म्हणून अशा कंडिशनल पार्टला म्हटलं गेलंय बुलियन इक्वेशन और बुलियन एक्सप्रेशन. सो दॅट इज नथिंग बट मॅथमॅटिकल इक्वेशन. सो ही tried to have combinations of those possible cases, and all those possible cases, whenever they are put in a table form, then it is known as truth table. Okay, so here it is the example of mathematical equation: y is equal to a or b. Don't read it as a plus b. Now onwards, here it is to be read as a or b. प्लस हा सिम्बॉल आपण ऑर म्हणून वापरणार. हे ऑर म्हणजे काय आहे? नॉर्मल इंग्लिश लाईक किंवा आयदर दिस और दॅट. करेक्ट. सिमिलर टू दॅट, इफ ए इज हॅव्हिंग हाय स्टेटस ऑफ व्होल्टेज और बी इज हॅव्हिंग हाय स्टेटस ऑफ व्होल्टेज, वाय आउटपुट will get generated with high voltage. The same technique it is going to represent. So here it is to be used with A or B. So this is the mathematical equation which is known as condition, statement logical equation, logical expression or boolean expression for that particular gate. Next, about the truth table. In this way, a table can be formed with inputs and with outputs. So here you can find A and B are considered to be two inputs. So how many cases will take place? So N stands for number of inputs. So in that case, number of cases will be 2 raised to N. Here N is 2, 2 raised to 2, 4. 4 possible cases will take place, and thus tabular listing of all possible cases of input and output, it is called as truth table. So here it is, as it uses digital inputs. So status of inputs will be either 0 or 1. So the first combination 0 0 0 1 1 0 1 1. So dependent on the condition, logic, here it is example logical addition, how it has generated the output. The same we will study in the first logic gate. Okay, so this is called as logical addition part. So here it gives truth table, tabular listing of all possible cases, all conditions are put in a table form. What is that condition part? It is known as mathematical equation or logical equation, boolean equation. Then what are the types of gates? Here the main concept starts. Types of gates. Gates are nothing but decision making circuits. So these decision making circuits are classified into mainly two groups. First one, basic or fundamental gates, without which no logic circuit can be designed. याच्याशिवाय कामच नाही चालू शकत. So basic or fundamental gates, they are three: OR gate, AND gate, NOT gate. Here you can observe all the titles are written in uppercase. So it's a rule to make the titles always with uppercase letters, capital letters. OR gate, AND gate, and the third one is NOT gate. The second type is derived gates. So that is nothing but NOR, NAND, XOR, XNOR. So basic or fundamental gates, they are basic. For any basic operation, these gates are essential. Okay, but combination of basic gates makes derived gates. Here it is. OR, you can recognize. N stands for NOT. So combination of OR and NOT, that becomes NOR. NAND, AND plus NOT. XOR, XNOR. So let's study about the different types of gates, and here it is the first part as basic gates. Here it is the first basic gate as an OR gate. This is the symbol of an OR gate. Here it shows minimum 2 inputs and only one output. Gate is a logic circuit with one or many inputs. So even though here 2 inputs are shown, there may be gate with 3 inputs, 4 inputs, like that. So here only 2 inputs are given. What is its condition? Here it is y is equal to A or B. Plus is used as an OR operator. Plus ha कशासाठी वापरलेला आहे? OR operation. So here it is going to perform logical addition. So rules for logical addition, they are 0 or 0 0. Don't read it as 0 plus 0. 0 or 0 is equal to 0. 0 or 1 equal to 1. 1 or 0 equal to 1. 1 or 1 equal to 1. The same part, it is listed how many possible cases will take place. N is the number of inputs. Then total combinations, they will be 2 raised to N. Correct. So here are 2 inputs. So here it shows 2 raised to 2, that is 4 combinations, 4 cases. Both are low, anyone low, other high, anyone high, other low, both are high, both or all inputs are high. So here it gives 0 or 0 0, 0 or 1 1, 1 or 0 1, 1 or 1 1. So what does this logical addition mean? It's not binary addition, because 1 plus 1, it has to give some 0 carry 1, 1 0. Here it is not binary addition, but it is a logical addition. So it means any one condition is true, output is going to be true. लक्षात येत आहे? एक जरी इनपुट हाय असेल तरी आउटपुट काय असणार आहे? हाय. The same can be explained by considering normal examples. First, suppose if I get a new book to read, I will enjoy my holiday with reading the book. Okay? Or if my friend asks me for cycling, surely I will go and I will enjoy my holiday. So what is the condition? Either reading a new book or going for cycling. म्हणजे कंडिशन मध्ये काय ठेवलेलं आहे? नवीन पुस्तक वाचायला मिळालं, मी पुस्तक वाचणार आहे, एन्जॉय करणार आहे, बरोबर? नाही तर दुसरी कंडिशन काय ठेवलेली आहे? जर मला सायकलिंगसाठी पार्टनर मिळाला तर मी सायकलिंगसाठी जाईन, बरोबर? म्हणजे याचा अर्थ हॉलिडे कसा एन्जॉय करायचा प्लॅन ठरलेला आहे, फ्लेक्झिबल आहे. एनी हाऊ एन्जॉयमेंट इज इम्पॉर्टंट, करेक्ट? सो व्हॉट इज रिक्वायर्ड? आयदर रीडिंग अ बुक or go for cycling. So the conditions may be book is not available and for cycling it is not at all suitable because it's raining. So the both conditions will say both input combinations are false. Both conditions are false. Okay, false, false. Condition false. Enjoyment will not be there. But if book is not available but for cycling my friend is ready, yes, I can enjoy with cycling. Okay, but new book is available for reading and for cycling no one friend is ready, then I will go with reading book. But here for reading book is available and for cycling also friend is available, I will do reading a book in the first half part of my holiday, that weekend, and the remaining part I will go for cycling. Anyhow I have to manage it. So that is nothing but selecting any one, that is the or operation. नेहमीप्रमाणे हे किंवा ते, that is logical or operation, which is nothing but logical addition. The same can be explained using a circuit. Here it shows a battery is used, two switches are connected in parallel and there is a bulb. So if a switch gets closed, current will flow and it will lit the lamp. If you make B switch closed, A open, here it is. Then also a path is available to lit the lamp. Or else if you close both switches, then also lamp will get lit up. But if you keep both the switches open, which is the first condition, lamp will not get lit up. Okay, so in this way OR operation is nothing but parallel combination of two switches. So that shows definition part, how to remember OR gate. It is a logic circuit which gives high output when either it's any one input is high or all inputs are high. बघा, एक जरी इनपुट हाय असेल आउटपुट हाय आहे आणि जेव्हा सगळे इनपुट्स हाय आहेत तरी देखील आउटपुट हाय आहे. सगळे बोथ म्हणायचं नाही, कारण गेट हॅज वन ऑर मेनी इनपुट्स, बरोबर? मेनी म्हणून तिथं टर्म काय वापरायची? ऑल. सो अबाउट द डेफिनेशन ऑफ OR गेट, इट इज अ लॉजिक सर्किट विच गिव्स हाय आउटपुट व्हेन इट्स एनी वन इनपुट इज हाय और ऑल इनपुट्स आर हाय. काय टर्म केली इथं? पहिला पार्ट हा कॉमन राहील डेफिनेशन मध्ये, इट इज अ लॉजिक सर्किट. सेकंड पार्ट कॉमन राहील, which gives high output when condition will be different, when it's any one input is high or all inputs are high. So OR gate is also known as any or all gate. OR gate चं दुसरं नाव काय? Any or all gate. In this way always you have to make the condition of that particular gate available and you can think accordingly. So gate, OR gate, it recognizes the input combination, any one is high, output high. So that is the OR gate, which is nothing but the logical addition provider circuit. Here it is also termed to be any or all gate. So our next gate is AND gate. Here it is the second basic gate as an AND gate. This is the symbol of an AND gate with minimum two inputs A, B. The output logic equation is A dot B, means you have to read A and B. Remember, dot represents AND operation. So what is an AND operation? It is nothing but logical multiplication. So logical multiplication rules are 0 and 0, 0, 0 and 1, 0, 1 and 0, 0, 1 and 1, 1. So when does it recognize the input? It recognizes the input part only when all inputs are high. So the truth table shows as A, B inputs, Y is equal to A and B. So both inputs are low, output low. Any one input low, output low for these two. And last, both inputs are high, output high. So it means here it shows only one condition. When it gives high output, only when its all inputs are high. Don't say both inputs are high, because gate is logic circuit with one or many inputs. त्यामुळे इथं म्हणताना आपण काय म्हणायचं? When its all inputs are high. So definition. It is a logic circuit which gives high output only when its all inputs are high. Okay, so the same logic can be represented as, suppose if there is no rain and bicycle is available, I will go for cycling. So rain and cycling. Okay, so these two conditions, they have to be tested. So here it is. Is today rain? No rain. Is bicycle available? No. I can't go for cycling. Is today rain? No. Here, even though the bicycle is available, I can't go because the combination is A and B. Means there should be rain and I have to go for cycling. So rainy season and cycling, correct? So here it is. Is rain today? No. Is bicycle available? Yes. But I can't enjoy. Okay. Is rain there? Yes, raining. Is bicycle available? No. I can't go for cycling. But there is rain as well as bicycle available. So in rainy season, I will go for cycling. I will enjoy both rainy season as well as cycling. So what are the conditions given? There must be rain and there must be bicycle available. Then I can enjoy rain, bicycle and rain both. Correct? So that is nothing but AND operation. The same can be explained here when two switches are connected in series. So here it is. As switch A, it says switch A is open and B is open. So 0, 0 condition. Lamp will not glow. Switch A is open and switch B is closed. Current will not flow, lamp will not glow. But the second condition is switch A is closed and switch B is open. Then also lamp will not glow because up to this current can occur. Okay, but next circuit it is again open. So the only condition when both switches are closed, then only the lamp will get lit. So that is the operation known as AND operation. Correct? So this is the second basic gate which shows dot. It is used as an AND operator. हा dot symbol जो आहे तो कशासाठी वापरला? AND operation साठी वापरला. Okay? So here it shows a logic circuit which gives high output only when its all inputs are high. Here truth table of 4 cases, as 2 inputs are there. If 3 inputs are there, n equal to 3, then 2 raised to n, 2 raised to 3 equals to 8. In 8 possible cases, it will give only one condition, when all 3 inputs are high. Likewise, this AND circuit can be used. The same, how can you use in practical way? For example, automatic water lifting pump mechanism, motor mechanism, automatic motor. So it is to be used. How you can design? If lower tank is full and upper tank is empty, then only the water has to be lifted. AND operation. जेव्हा पाण्याची खालची टाकी भरलेली आहे आणि वरची पाण्याची टाकी रिकामी आहे, ठराविक लेवलपेक्षा पाणी खाली आहे, तेव्हाच काय सुरू झाला पाहिजे, वॉटर पंप. दॅट इज अँड ऑपरेशन. Practical usage of this AND gate. So in this way, dependent on the conditional handling, we can use this AND gate. So the next third basic gate is a NOT gate. Third basic gate as NOT gate. Here it shows the symbol, a triangle along with a bubble sign, or a triangle with bubble sign at the input side. Any one symbol you can use. So here it shows only one input and one output. So that is the part included in definition of gate. Gate is a logic circuit which can have one or many inputs. Okay, so this is the exceptional gate, as with one input one output. So here it is said to be having unary operand. एकच input आहे आणि ते input आपण काय करणार आहोत, invert करणार आहोत. Why? Not A, not fail means pass, not pass means fail, not true means false, not false means true, exactly opposite. So here it is said not of A, either complementation or inversion. So the rules are A is 0, Y will be 1. A is 1, Y will be 1. Y will be 0. So Y is equal to complement of A, not of A, and the sign is known as overhead bar. So this is used as NOT operator. That is inversion operator. Okay. So overhead bar is used as inversion or NOT operator. So as we studied in number system, how digit 0 becomes 1 and digit 1 as 0, same, which is nothing but one's complementation. That is the complementation part. Here it is mentioned. So here it is used to give one's complement of applied operand. So if input is 0, output becomes 1. Input is 1, output becomes 0. Thus, this is a NOT gate, which is also known as an inverter. Okay, so here it shows the definition part as when does it give high output? It gives high output only when its input is low. So it is a logic circuit which gives high output when its input is low. जेव्हा त्याचं input low आहे, हमखास output काय येणार आहे, 1. So this is about the NOT gate, and here it shows if two gates are cascaded, means they are connected one after another, that is called as double inversion. As you have considered overhead bar, it generates the complementation. So here it is, output of first NOT gate becomes the input for second NOT gate. So first input A, output of first NOT gate, complement of A, it becomes input to the second NOT gate. So 2 times it gets inverted. So the output is said to be Y is equal to double complement of A. Here this double complement cancels each other. How? Here it is, input A is 0, complement of A becomes 1. Again it gets inverted, it becomes 0. So whatever is the input, it appears in the same way at the output. So here it is, input is 1, at the output of first NOT it becomes 0, but again it gets inverted, here it becomes 1. So whatever you have given input, it will appear in the same way at the output. If you connect 2 NOT gates one after another, that is the main usage of this inverter. Having double inversion means making the same input available at the output, which is also known as buffer, memory or latch circuit. Whatever is the voltage level given, it remains same, which is nothing but saving particular concept in memory. That is nothing but memory save concept of calculator. Intermediate answer that gets saved in the calculator, you can recall it. So whatever is given as the input, it will be the same at the output. So here it is, the symbol of buffer. You can observe in the NOT, this bubble here it is disappearing, means if you attach a bubble sign, it is going to invert. If you remove that bubble, whatever is the input, it will remain in the same way at the output. So what are the basic gates OR gate, AND gate, and the third one is NOT gate. OR performs logical addition, AND performs logical multiplication, and NOT performs inversion, that is complementation. Using these basic gates, we will study further about derived gates, logical equations, how to simplify them, how to design logic circuits. So take down all these symbols, truth tables, logic equations, main points. We will move further with the next session. Thank you.